On this second video for this section, we're going to be looking at functions of this form, y equals 1 over x to the n, with n in the positive integers. So if n is 1, then we get this thing. It's called a hyperbola. And we'll talk about hyperbolas later in the course. But at this point, you need to know this basic one, f of x equals 1 over x. Okay, now this one, you have a center at the origin, right? And if you want to know where that point is, that's called the vertex, and this is a vertex of the hyperbola. There's two of them. And you would just go over 1 and up 1. Now, if there was a 2 up here, you would go over 1 and up 2 to find that point on the hyperbola. Okay, and same thing over here. You would go over 1 and down 2 if there was a 2 up here. Okay? But it's basically this shape. 1 over x. We'll see other kinds of hyperbolas later where the asymptotes are not vertical. This dotted line here, these are asymptotes. They're lines that the graph approaches as you go further and further. Right? You go further and further, it approaches this line. Okay, 1 over x squared. So here we have an even index on the denominator. And both of we call these branches, the two branches, right? They both go up. Well, as you approach the y-axis, they go up instead of going down like this did. Right? It goes up. Right? We'd still think of this as the center. It's not really a center, but that would be a vertex there, and that would be a vertex there. Over 1, up 1. Over 1, up 1. Okay? So this is different. That was 1 over x, so the x is in the denominator. Here, you have an exponent with the n in the denominator of the exponent. So this is like a square root, a cube root, a fourth root, a fifth root, etc. So a square root looks like this. It's actually a parabola that goes sideways, but you cut off the bottom. If you wanted the bottom part, you'd have to put plus or minus square root of x, which would not be a function, right? But it stops, and so it has an endpoint. The endpoint, it happens to also be called the vertex. So that's the vertex there. The endpoint of these things is always important. Okay, so it looks like that. You go over 1 and up 1 because the coefficient here is 1. If there's a 2 sitting here as a coefficient, you go over 1 and up 2. Right? Okay, and if it was n equals 4 or n equals, that would be the 4th root or the 6th root or the 8th root, it would look very much the same. Now for n equals 3 or other odd n's, it doesn't have an endpoint. It just continues. It kind of looks like the cube root sideways, or the cube sideways and flipped over. So this part on the right hand side looks like a cube root that's been flipped over sideways. And this is the same thing, but it's going the other direction. Right? If it went this way, it wouldn't be a function. But it goes the other direction. And the vertex is this point right here. In this case, the origin.